Alright, let's see if this works. So this is what my truck has looked like, and I've been driving it since June, and it is now January, so June 25 to January of 2026. The reason, if you haven't already guessed, is because I have the infamous HVAC leak. The source of the water comes from this area, and since I've pulled all the carpet back, it likes to soak up everything. It doesn't get nearly as bad, so I've been driving it. Supposedly Rivian has a fix coming, but it's been 6 months and I'm tired of waiting, so I'm out of warranty, so I think I'm going to try to figure this out myself. But even right now, it's dead of winter, you know, very little humidity, and this is still damp in here, just a little bit of insulation. I think eventually what I'm going to do on top of what I'm doing now is pull all of this interior out, the whole center console and the carpet, and pull the whole airbox possibly out, hopefully not, but at least figure out if there's any other engineering failures on this thing before I put my interior back together. Now let's show you where I'm at right now with what's going on underneath the truck and what I believe is actually causing the issue. Go around under here. So I've pulled both of the first two lower panels off the truck. I'm also checking for suspension squeaks at the same time, and I found a couple places, especially on these welded early front cross members, that are 100% causing squeaks, and there's nothing you can really do about it. I might make a separate video on that, but let's slide under here. So this middle panel is really immediately behind the front tires, covers up all the connectors for the large battery pack. I've already checked all of these with a voltage detector, and none of these wires are actually hot while the truck's sitting here. So above this panel, if you look up here, you see this port directly above. I might get this on up in here. So when I found this, there was some butyl tape, like silver coated butyl tape, that was stuck all around this opening, and one of the service centers told me they did a little bit of butyl tape work to try to fix the leak, and it did actually reduce it some, but did not fix it. It's still leaking pretty decently. So I've already pulled all that butyl tape out. If I can, I'll try to put a picture in this video of what that looked like before I pulled it out. But what's interesting is there's about an 1/8 inch gap between the bottom of this drain and this metal panel right here. So the 1/8 inch gap here. So what's happening is the water is dripping, and this is the little check valve that goes in there. This is the updated version of the check valve that still doesn't really do anything. So this sort of hooks right in there. So water comes out, and if anything tries to go in, this acts as a stopper. It gets pushed up. It's really nice and floppy, for no better term, and seals itself there. The theory there is that if you're forwarding water that's that deep, the water pressure will push this shut, so you won't get dirty, nasty water into your HVAC box, which is great. Nobody wants that. The problem is the water drips out of this, and I don't know why, due to airflow, due to G-forces, to whatever. It does not drip just straight down. It gets on this lip here, and then from that lip, we've got a little bit of foam tape right there, and it's all the way around this circle here. That foam tape is the bottom of your HVAC box inside the truck. This right here is the bottom of the interior of the truck, and so that water, foam does not stop water. That water is getting onto this little lip and then draining into the truck. So that is what's happening. What I'm going to do is put a tube extension on this drain with a check valve down below, and over time we're going to see if it works. I don't see any reason why it wouldn't. But while I'm at it down here, I'm going to extend this down and put a check valve down below, a different type of check valve. So it will still prevent water from going into the truck while allowing the condensate to drain. But I'm also going to take some silicone sealant and I'm going to seal this whole area after I put my hose in, because if you go fording deep water, which less than 1% of us ever do, I never have, but if you do, this whole hole is going to allow water into the cabin. So I'm going to fix that problem while I'm here. It's really interesting. If you look here, the plate that covers this area up is a pretty thick steel, and the condensate literally, like I said, it drips out of that hole just everywhere in here. It just drips. So they did not care. Once it got to that point, they're like, it can drain wherever it wants to. So the condensate is getting down. What many people don't realize is that air conditioning condensate is a slightly acidic water. So it can be corrosive to different types of materials. It grows algae really well because of the acidity, but it's rusting out this panel. If you look here, so it literally drips straight onto this, rusting this panel a little bit. The acidity is evidently eating away at the finish just a little bit. It's not bad, it's barely surface rust. But if you notice here, you've got this rust that's built up on the bottom of the battery right here. And you got rust that's built up on this, looks like an RTV type or silicone type sealant that's sealing the battery shut. So you got rust built up here. So what that tells me is that the condensate from the air conditioner is constantly challenging the sealant right here, which I don't prefer. I mean, this sealant should 100% keep water out. Everybody agrees there, but from an engineering perspective, you do not want to be constantly challenging your only system of keeping water out of something like a lithium battery, where if water gets in, it's a bad deal. So I'm going to do some work here. I'm going to figure out my routing method, and then I'll show you the hose and the check valve that I bought. Time will tell if it works, but I'm going to take a stab at this and see if I can figure it out. So those of you who know can stop screaming, or if you're an electrician, because I just realized after I took my last video that I'm an idiot, because my voltage sensor 50 to 1000 volts, but the little V with the squiggly line means alternating current, pretty sure. And I remember back in my brain, which tends to get smaller with age, I don't think you can detect DC voltage with the voltmeter, so I'm playing it safe. I got these generic Amazon gloves that I found. Definitely don't trust Amazon, but you know, better than nothing. I'm not going to pay $300 for gloves that I can't actually do anything in. Again, these wires are very well shielded. There is no damage on them anywhere. These are like shielded wire within a shield. These have the really thick paper wrap on them. So, you know, not the brightest moment in my life, but you know, I was born in a birthing center, homeschooled from South Carolina, so probably half of y'all watching this, you drive EVs, you probably wouldn't care if I died anyway, but you know, gotta die of something. So where I'm at right now is this hose, which if you look at the end of it, this is a silicone high temperature heater hose. So it's made for coolant, so it'll withstand any kind of temperatures we'll ever see up in this cavity. It does not quite fit on there because the gap right here at this end is less than the rest. So the horrible idea I've come up with, that the only way I can figure out how to get this on, is I'm going to take this, made myself a guide out of about 1,000 layers of painter's tape to keep it centered inside of here without damaging the HVAC box. So I'm going to drill that hole a little bit bigger. I've already checked and made sure that my, what's inside of this box? The evaporator. The evaporator is about 3 inches up. I've made sure I can't hit that with my apparatus. So what I don't want to do is damage this line, because that's the air line going to this corner. And if I cut a hole in that, I'm just guessing that this corner is going to drop very quickly. And I've got enough room under here that I probably won't die, but not enough that I'm super comfortable. So I'm going to take a stab at this, be very safe. I'm going to drill that hole out. I've already taken my bore scope, inspected around this circle. There's nothing in there. It's just a hole. Looks just like that. It's interesting. This circle is like that big, and it's sort of offset in this. So the only thing up there is that right there. So I'm going to drill pretty easy, careful, slow, and let's see what happens here. It's me again, Margaret. Name that comedian, if you know. So I was able to disconnect this airline because it has a pretty long standoff, and tuck it back behind this clip off of the high voltage, and get my hole saw in there, and that's as much clearance I believe as I need. I decided what I'm going to stick this up in there with. I think I'm going to epoxy it. I think that'll have the best chance, but right now it's boop. Nice snug fit. So that's going to work. So I'm going to figure out my hose routing and how long it needs to be cut, and get that figured out, and then get all this sealed up. A little bit of bare metal up there, but I'm going to totally cover that up with a really high quality silicone product, so I'm not worried about that little bit. It's going to suck if anybody wants to remove the air box in the future, but this has had the air box replaced and all of the above in their efforts to stop the leak, so hopefully it does not need replacing anytime soon. Let's take a look at this hose and the valve. Definitely the longest hose I've ever had between my legs there. So this other end, I don't know if I can do this. This is a valve I found. Yep, I'm not good. If I ever lose one of my hands, I'm going to be screwed. Let's see what we can do here. There we go. Maybe you can see, maybe it's too bright. This actually comes apart. We've got it's got a, here we go, this might actually help. Got a 3 sided, what do they call these? These are duck bill check valves, and they only flow one direction. I'm not talking about the band. So this is going to mount in there somewhere like this, pointed down. I could cut this off as high as there, depending on where I mount it. But the hose will go in like this. I'll put a hose clamp on it, mount it somewhere. Water will be able to drain out, but water cannot go back in. I've actually tested this with my Makita 18-volt blower, and had really good flow one direction, and absolutely no flow trying to reverse blow through it. So I'm really confident that this will fix the issue. So this is where I'm at now. So we look in here. So I epoxied the silicone hose over the downspout of the HVAC drain and filled the gap that was up there between the drain box and the body with 3 different goes at filling it with that silicone, just to make sure it cured up okay. And it's actually still, you can see it moving around. It'll remain that flexible, but it's not fully cured yet. So what's going to happen is, instead of dropping straight down, look at this mark. We know that we've got this bolt is one of the bolts that holds this panel on. We've got a rust spot, so we know we got a piece of metal that sits flat here. So what I've got is, I've got it going to the side of that piece of metal and just barely sticking below, about a 1/2 inch to the bottom, and that's on purpose so this metal plate, probably a strengthening plate of some sort, is pretty beefy, probably has something to do with side impact, will hold up and push up on that, sort of give it some resistance to gravity. And then I've got this angle cut on it so that it doesn't block the path of the water. So if you look at where that's going to dump on the plate, so we used to dump straight down and most of the water would drop in this general area. And what's interesting here is it really was filling this up while the truck's sitting still or just sort of driving really easy. This would have to fill up with water before water would come up out of that, and then it would just rush over the sides, and it looks like it tends to rush over towards the driver's side and then drain out around the battery where we didn't want it doing that. So what I've now got is that tube is going to drop in right here. So this is going to push upwards, the tube is going to drop into this channel, and this channel is going to immediately dump the water out onto the ground. So we're never ever going to be pulling water up. And we're also not going to be challenging this silicone that's sealing the battery shut. So I think it's a better all-around situation. We'll also be able to inspect from the rear looking forward. There's going to be a small gap. We'll be able to actually see that tube sitting here. Make sure it's sitting correctly. Inspect it over time. Make sure nothing's happened. It hasn't moved. Make sure water's coming out, etc. So I think it's going to be a better situation. I am going to get this tied back up. I am going to rethread at least 2 of the bolt holes on this thing, where I don't know if it's at factory or when the service center removed it to replace the little drain valve, but I've got a couple cross-threaded bolts. They were super tight. They zipped them in with impact, which is not cool. So anyway, I'm going to work on that, get this tied back in, and then move on to the next thing. So just a couple tips on putting this panel back in. So I didn't notice when I took it off that it's actually a double layered, and what I mean is there's this layer that bolts on, which is what we were looking at from the top, and then there's just another layer. I'm not sure why, but it sort of gives you, I would guess, maybe a cushion for like impacts if you're off-roading. But what we're going to end up with is having a 0 gap here. Push this up, you can see pretty close to 0 gap. Water would still drip out, but I wanted to have an inspection hole, so I bent this bottom layer down a little bit. Not going to hurt anything. Look in there, you can see where our hose is and how it's going to sit. So it's going to come out of that channel. This is going to be all the way flush. It's not flush yet because some bolts are holding it. And then the water's just going to come out here. I should be able to like barely peep in here over time as I want to, and take a look at it if I want to. I will say this metal was extremely hard to bend. It's pretty beefy stuff for how thin it is. But a quick tip is, you'll notice I've got all of the bolts in everywhere, and I'm going to put the nuts in also, and then I'm going to make sure the alignment's good before I tighten anything. Don't want to tighten one and have it hold it in place and be fighting it while I try to get the rest of it lined up. What I've also done here is put a little bit of anti-seize on every one of them, even going into steel. You shouldn't have any galvanic corrosion with steel on steel, but it's not going to hurt anything. But especially along the front, specifically these 2 spots, there's 2 of these on each side to go directly into aluminum, and I think we're going into aluminum. And this, I know this is aluminum, and I'm not sure if the nuts that are on their side are staked on, like steel nuts that are staked in, or if they're aluminum that are welded. Didn't really spend the time to figure that out, but there's anti-seize on all of it. So my little bin, if you're looking from the front back, just a little bend down, like a 1/4 inch. Not going to hurt anything at all, and allows the water to get out a lot quicker or immediately instead of being able to pool up, which it is condensate. Really not much water that comes out of there in the grand scheme of things, but hopefully this gives me a tiny little inspection window. Again, I can look in there and take a peek if I want to without having to pull the panel. Otherwise, I'll run my borescope in from somewhere and inspect it if I feel like I need to. Let's see. Other quick tip I wanted to say is, I could have said this in the very first video. The truck is currently in tire change mode. It's not in its highest suspension because I wanted to be sitting in this normal suspension while I'm looking for suspension squeaks and rattles, because I'm also doing that at the same time. It's in standard height, but I put it in tire change mode. And what that should do, I'm not certain on this vehicle, but at least on my older, I have an old Audi in 05, actually the first mass-produced car with 4-corner air suspension. But when you lock the suspension, hopefully what it does on this one, I'm counting on it, is that it cuts off each corner from all the other corners, so that if you do have a bag failure, only one corner can drop, not either 2 corners together or all 4 corners at once. I'm not sure how this valve body is set up in the air suspension. On the Audi, when you lock the air suspension, it actually shuts all 4 corners off, so if one corner goes, the other 3 corners are cut off from it. So that's a safety thing for being under an air suspension car. Generally speaking, I would not be working under this if I didn't know that if the suspension fully collapses, I would not be fully crushed. I know where my bump stops are and how much gap I have above my wheels, and it would stop. I've got enough space in here. It's not going to drop that far, so it would suck and be scary, but it's not going to kill me. But in general, working on any air suspension car, you should put jack stands under it if you're under it at all with a really tight clearance. Like if I didn't have the clearance, I'd have jack stands for the just in case possibilities. I'd put those hopefully in a place that's really substantial and it wouldn't damage anything. If it does fall on it, I'd put them like almost all the way up under the frame where it would be snug. So I would have put them probably right in this area, which is right where your jack points are anyway, but I would like snug a jack stand right up under there if I did not have enough clearance to save myself in the event of a air spring failure. I've actually had an air spring fail on this truck while I was just cruising through a parking lot one day, and that resulted in them replacing the whole front air suspension system and updating the shocks to the newer updated models and all that. So it does happen. This is the only vehicle that's ever happened to me on. Thankfully I was not under it when it happened. So they do happen randomly, so just be aware of safety, coming from a guy who was poking around on high voltage lines. Take that for what it's worth. Just a quick note about the torque specs on these bolts. Got no clue what it is. I could look it up, but I'm not super concerned about it, just for 2 reasons. So these are grade 10.9 bolts, very hard, 6mm diameter. So I know that old trusty Makita here can't possibly break them. Doesn't have near enough power. However, old trusty Makita here pulled all of these out except for the one that was cross-threaded. It doesn't have any more reverse torque than it does forward torque. It actually is probably slightly less due to inefficiencies in the gear set. So I just sent it. They're all in as tight as this drill will get them. It pulled them out, which means it put them back just as tight as they were. Drill can't break a 6mm bolt. No chance of that. Couldn't even break probably wouldn't break a 5. Might break a 4 at 10.9 hardness. So I just sent it and done with it. No big deal. So this is what this looks like, all tied up, nice and snug. Just a little bit of drip, and I doubt we can see all the way through there. I can see the hose. Let's see if we can get light from another direction. There we go. You might be able to barely see that hose up in there. Yeah, very difficult to see up in there, so can't see it on camera, but you can see it visually. So tiny little inspection window idea works. The hose is tucked up in there nicely, just like I want. And I'm gonna continue with putting all this trim back. By the way, 3 different size of fasteners on this trim. You got T25, T27, T20, and 10 millimeters. So 4 different sizes. Really, guys, we could do better. Just stick with T25 with everything and call it a day.